Every time you write a solution in an interview, your interviewer is silently thinking of two things. 1. How fast is this running? 2. How much memory it is using? And here is the truth. If you cannot answer these two questions, it does not matter your answer is correct, they will still reject you. If you cannot answer these two questions, it does not matter if your answer is correct, they will still reject it. Today I am going to explain time complexity and space complexity in the simplest way possible. No complicated methods, just real world examples that you already understand. Let's go. Let's start with time complexity and forget code for a minute. I want you to think about something that you already do in real life. I give you a physical book, a telephone directory with thousands of names inside. Your job is to find my name, Sonia. How would you search for it? The way you search tells about the time complexity. The way you search it, that tells us the time complexity. Let me draw this for you.
Here is our book, telephone book with 1000 names, and you have to find Sonia. Method 1. You start from page 1 and check every single name one by one. Name 1, Aditya. Name 2, Bhavna. Name 3, Chetna. You keep still going on and you find Sonia at 867. In the worst case, you checked 1000 names, and if it has 2000 names, then you have checked 2000 names. Input double, steps double. This relationship is called big O of n, that is linear.
You take the first name, that was Aditya, and compare it with every other name, like compare with name 2, that was Bhavna, name 3, Chetna, and so on. 1000 names times 1000 comparisons. Thousand names into 1000 comparisons. That will be steps, 10 lakh steps. For 2000 names, it will be 4 million steps. So input double shows steps multiplied by 4. This is big O of n square. This is very slow and it should be avoided. Method 3, when book is sorted, from A to Z, open middle, so 1000 names, middle will be 500, page. Let's say page 500, M names, S comes after M, throw away first half, 500 names, throw away remaining. One middle again out of 500, page 750, page 750, let's say R names, still S names comes after R, so throw away first half. Again X name, 250 names, and we are throwing away remaining. So keep doing this, you keep cutting the problem in half every single step. 1000 names, you find Sonia in just maybe 10 steps. Big of Logan, that is very fast, and this is, you can guess, binary search. Method 4, book has an index at the back. So A is on page 1, B is on page 45, and so on. S is on page 612, and you can go directly to this page to find Sonia. So that is done in 2 steps only. So step 1 is open index, step 2, go to page 612 and find Sonia. So the input size does not matter at all. It is the constant time, and this is the best possible complexity. So here is the summary. Big of 1, check index directly, that was the fastest one and gets solved in 1 step. Big of log n, very fast and 10 steps. big of n, that is 1000 steps acceptable, and big of n squared too slow, and avoid this. Now that we understand time complexity with a real example, let me show you how to spot it directly in your code. 3 rules, remember these and you can calculate time complexity for any code you write.
So here is the rule 1 loop big of n. So we have an array 2, 4, 6, 8, 10. We will start from 2 and we will go forward. Visit each box once. 5 elements means 5 steps. 100 means 100 steps. N elements means n steps.
Rule 2, loop inside loop big O of n square. Let me show you with a real example. For example, we have an array 1, 3, 5, 7 and target sum is 8. Like find two numbers that add up to 8. So we will take 1 first and add it to 3, and the sum is not 8, so it is not required. So 1 plus 5 is 6, that is also not, and 1 plus 7 is equals to 8, so this is the success. Take 3 plus 1 is 4 and 3 plus 5 is 8. Take 5 in the same way, we will get 5 plus 3 8. Every number checks every other number. 4 numbers 16 checks. So 100 numbers, so 100 into 100, that will be 10,000 checks. So loop inside a loop is big O of n square, and we have to avoid this. Rule 3, every time your code cuts the input in half at each step, that is big O of log n. Simple example, let's take an array 1, 2, 3, 4, 5, 6, 7, 8. I want to find a number 7. Step 1, check the middle, that is 4, and is 7 bigger than 4? Yes. So throw away left part, like these elements we will throw away. So the new array will be 5, 6, 7, 8 will be remaining. Check middle again, that is 6 now. So we will throw the left half away. So now the remaining is 7 and 8. We will check the middle again, and the middle is 7 now. So we were going to find the 7 and we found it. So 8 elements, only 3 steps, cut in half each time. So this is big O of log n, and it is very fast. So here is the space complexity. Scenario 1, you solve the problem completely in your head. No paper needed, no notebook. You use the same amount of brain powers no matter how big the problem is. So this is big O of 1, that is constant. Best possible way. Scenario 2, the problem has n numbers and you write each one down on a separate page. 10 numbers, 10 pages, 1000 numbers, 1000 pages. This is big O of n, that is linear space. Scenario 3, you write a grid with a rows and with n rows and n columns. N rows and n columns. This is big O of n square space, rare but it exists. The most important rule, we measure only extra memory your code creates, not the input. The input is already here, just what your code adds on top. Look at these two examples. First, you create a new array of size n that creates extra boxes in memory. As n grows, memory grows. This is a big O of n space, and it uses extra memory. Second example, that is you create just two variables, that is left and right, two boxes, whether n is 10 or 10, whether n is 10 or 10 million, still only whether n is 10 or 10 million or 10,000, still only two boxes like these two only, that is big of one space, and this one is the best one. When interviewer asks, can you solve this with constant space, they want big of 1, no extra arrays, no extra list, just variables. Now let me put everything together with one real problem so you can see exactly how to calculate time complexity and space complexity for any solution. The problem, pair sum. You got a sorted array of numbers and a target. Find two numbers that adds up to the target. I will show you two solutions and calculate time and space for both of them. So now next problem is pair sum, and our sorted array is 1, 3, 5, 7, 9, target is 10. So we need to find which two numbers adds up to 10. So the answer is 1 plus 9 equals to 10. But how we find it? That determines our complexity. Solution 1, brute force, take the first number 1, add it to every other number, 1 plus 3, 1 plus 5, 1 plus 7 and 1 plus 9. So we found it here. Every number checks every other number. Time complexity, big O of n square, because it is loop inside loop, that is two loops. So space complexity will be big O of 1, and we only use two counters, no extra memory. So time is bad and space is good. So but interviewer will reject this because of time. Solution 2, two pointers, one pointer at the very left, that is 1, and one pointer at the very right, that is 9. Add them, 1 plus 9 equals to 10. So found it one step. What if our target was 12? So 1 plus 9 is 10, that is too small. So move the left pointer one step right. Now 3 plus 9 equals to 12, found it. What if our target was 8? So 1 plus 9 is 10, that is too big. So move the right pointer one step left. Move the right pointer one step left. Now 1 plus 7 is equal to 8, found it. We never loop twice, one pass through the array. Time complexity is big O of n and space complexity is big O of 1. So because only two variables are used, left pointer and right pointer. So this is the best one. Let me show you the comparison between brute force and two pointers. Same correct answer but completely different complexity. Brute force gets rejected. Two pointers get approved. This is why time and space complexity matters more than just getting the right answer. Here is everything in one place. For time complexity, one loop is big O of n, loop inside loop is big O of n square, that we need to avoid, and cutting in half is big O of log n, that is the great one, and no loop is big O of 1. For space complexity, creating a new array is big O of n, and using only variables is big O of 1, that is the best one. And always we need to ask these two questions to ourselves: how many steps does my code take, and how much extra memory does my code create? Answer these two and you are ahead of 80% of candidates in your interview. From next video, we will start DSA patterns, sliding window, 2 pointers, hash map counters. For every pattern, we will calculate time and space complexity together, so you never have to guess again. Subscribe so you get that video the moment it drops. And tell me in the comments right now, before watching this video, which one was confusing you more? Time complexity or space complexity? I read every single comment and I reply.